Welcome. Welcome to the second lecture of probability theory. Again, we are focusing on the word experiment. The experiment refers to the process which results in different possible outcomes or observation. An experiment is called random experiment if it follows following two properties. The first property is if all the possible outcomes are known in advance. And second one, none of the outcomes can be predicted with certainty. To understand this random experiment clearly, we need to have an example. For a moment, let us suppose we are throwing a dice. While throwing a dice, all possible outcomes, just list it off. All possible outcomes are any number between 1 to 6 may occur on surface. These are all possible outcomes, and that you are knowing it in advance. Okay. The second property, none of the outcomes can be predicted with certainty. This indicates that while throwing a die, any number between 1 to 6 may occur, but you are not sure which number may occur. Look, this throwing a die experiment follows both the properties. So, this experiment is called a random experiment. So, by and large way, if you just want to conclude, you can conclude it this way, that an experiment in which all the possible outcomes are known, but you don't know what will happen with certainty, is termed as random experiment. Event. We have seen it earlier also that any experiment, outcome of an experiment is called an event. Okay. There are different type of events. Generally, these events are denoted with capital A, B, C, or anything which you wish to. An event can be certain, it can be random, it can be an impossible event. Let us see it one by one. First of all, certain event, or you can say a sure event. An event which is bound to occur in any case when a certain random experiment is performed is called certain event or sure event. This is what exactly the word itself says. Certainly it may happen, surely it is going to happen. This type of event are called certain event or sure event. Let us see it with some example. While throwing an unbiased cubic die, the occurrence of any one number from 1 to 6 is a certain event. It is very natural. If you just throw a die, naturally any one of those 6 numbers may occur on surface. So it is going to happen surely. That is why this type of events are called certain event. Now let us think of random event. An event which may or may not occur when a certain random experiment is performed is called a random event. Look, here the word used is random experiment. We have defined it earlier which type of experiments are called random. If all the possible outcomes are known in advance, but none of the outcome can be predicted with certainty, that experiment is called random experiment. Naturally, this random experiment always generates random event. For example, in a throw of an unbiased cubic die, the occurrence of number 6 is a random event. Naturally, throwing a dice is a random experiment. Getting a number 6 on surface is a random event. So random experiment always generates random event. Third type of event, which is called an impossible event. The word itself suggests that it is not going to happen in any condition. Even though, let us define it. An event which can never occur with a certain random experiment is performed is called an impossible event. For example, in throwing an unbiased cubic die, occurrence of number 7 is an impossible event. Just think it off. While throwing a die, total number of possible outcomes are getting number 1 to 6. 7 is never going to happen. It is never going to occur on surface because it is not there at all. So in that case, occurrence of number 7 is an impossible event. Is it clear? Now, these events can be classified. Classified in the sense that there are some specific events. Certain events are called equally likely event. As the word suggests itself, equally likely. Now let us define it. Two or more events are said to be equally likely if any one of them cannot be expected to occur in preference of the others. Let us see it with example. In a tossing of an unbiased coin, there are two possible outcomes, head and tail. Head is likely to come up as same as tail is likely to occur. So head and tail means getting head and tail are equally likely. In a throw of an unbiased cubic die, any number between 1 to 6 may occur on surface. Look, when you use the word unbiased, that means likeliness of getting 1, 2, 3, 4, 5 or 6 are same. So they are called equally likely. Let us add one more example. In drawing a card from a well-shuffled standard pack of playing cards, there are 52 cards in a set of playing cards, pack of playing cards. Let us suppose we are drawing one card from it. Any card out of 52 cards, they are likely to come up. They have equally likeliness. So, this event is called equally likely events. Collectively exhaustive events. What do you mean by this? Events are said to be collectively exhaustive when their totality includes all possible outcomes of a random experiment. In a tossing of an unbiased coin, possible outcomes are head or tail. So exhaustive number of cases are 2. Total number of possible outcomes are 2, head or tail. That totality in the sense all 2 possible outcomes, they are called exhaustive. In a throw of an unbiased cubic die, possible outcomes are any one number between 1, 2, 3, 4, 5, 6. So exhaustive number of cases are 6. In drawing a card from a well-shuffled standard pack of a playing card, possible outcomes are anything between 1 to 52 cards. So total number of collectively exhaustive events are 52. Is it clear? Complementary events. As the word itself gives its meaning, event A is called complementary event of B and vice versa if A and B are mutually exclusive and exhaustive. Again, here the word used is mutually exclusive and exhaustive. Try to separate these two words. Mutually exclusive, I am referring it to a definition of mutually exclusive. What was the definition of mutually exclusive? Two events are said to be mutually exclusive if happening of one simply discards possibility of happening others. Exhaustive event. Exhaustive. Recently we have defined the word exhaustive. Exhaustive means total number of possible outcomes and which gives you the totality. Totality means all possible outcomes are there. Right? Okay. Coming to this part now, how these complementary events are. First one. In a tossing of an unbiased coin, occurrence of head and tail are complementary. Naturally, while tossing a coin, if you get a head, you are discarding possibility of getting tail. And there are only two possibilities while tossing a coin, they are head and tail. So both the things, mutually exclusiveness and exhaustiveness, both the things are being taken care of. That is why they are called complementary events. In a throw of an unbiased cubic die, occurrence of an even number. Even number means a number which is divisible by 2. Means it is 2, 4 and 6. An odd number. Odd number means a number which are not divisible by 2. They are 1, 3 and 5 in case of throwing an unbiased cubic die. Look, naturally, if you make all the possible outcomes becomes 1, 2, 3, 4, 5, 6, means it comes to a totality part, that means exhaustiveness is being taken care of. Second, mutually exclusive. Mutually exclusive means whenever you are getting an even number on surface, naturally odd numbers, possibility of getting an odd number is being discarded. Whenever you are getting an odd number, possibility of getting an even number is being discarded, so they are mutually exclusive. So they are called complementary events. In drawing a card from a well-shuffled standard pack of playing card, occurrence of black card and a red card. If you just analyze this pack of playing cards, there are 52 cards in it. Everyone might be knowing it. Among these 52 cards, there are 26 black color cards and 26 red color cards. Naturally, black color and red color are the only two colors available on those 52 cards. While getting a black card, you are discarding possibility of getting red. While getting a red card, you are discarding possibility of getting black. So they are mutually exclusive and exhaustive. That is why they fulfill both the condition. One is mutually exclusive and second is exhaustive. That is why they are called complementary events. Simple event. As the name suggests itself, an event is said to be simple when the occurrence of a single event is considered. What do you mean by this? In tossing of two unbiased coins. Look, now I am talking about tossing two unbiased coins. While tossing two unbiased coins, how many possible outcomes are there? Total number of possible outcomes are 4 now. In the first case you will get head, in the second coin again you will get head, means head, head. First you will get head, second you will get tail, means head, tail. Third is, first you are getting tail, second you are getting head, means it is tail, head. And the fourth possible outcome is tail, tail. In both the cases you will get tail. Just think of a simple event, occurrence of one head. Look, one head. That itself is a simple event. Means this consists of only one possibility, occurrence of one head. Similarly, in a throw of two unbiased cubic dice, again what I am talking right now about is throwing two unbiased cubic die. Look, with a single die you have 6 different possibilities. If you throw two unbiased cubic dice, total number of possible outcomes will be 36. All this 36 can be listed. It can be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Similarly with 2, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. And similarly, if you proceed it, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So total that matrix will be 36 different outcomes can be generated, of which occurrence of 1, 6. Among these two, one of them is 6. That event is called a simple event. The definition of this simple event will be clear once you understand the compound event. Compound event. An event is said to be compound when the joint occurrence of two or more events is considered. We are taking the same example to make it more clear. In tossing of two unbiased coin, occurrence of one or more head. Look, two coins are tossed. Occurrence of one or more. What do you mean by more head? It can be one or it can be two even. So two possibilities are integrated. Since it is integrated, it is called compound event. In a throw of two unbiased cubic die, occurrence of one or more 6. Okay. Again, a word used is one or more 6. Two unbiased coins are tossed, so two unbiased cubic dice are thrown, so there are more possibilities. Occurrence of 1 or 2, 6. 6 is a number which is on surface. So naturally here you are combining, you are compounding two events. That is why it is called compound event. Mutually exclusive event. We have seen it earlier also, but again we are viewing it in terms of some of the examples. Two or more events are said to be mutually exclusive if they cannot occur simultaneously in the same trial. That means the occurrence of one prevents the occurrence of other. Or you can put it this way in words. Occurrence of one simply discards possibility of happening others. All these words are same in meaning. You can use any words among these three. Examples of mutually exclusive event. In a tossing of an unbiased coin, again we are tossing a single unbiased coin, getting a head or tail. Look, While getting a head, you are simply discarding possibility of getting tail. If you get a tail, naturally you are discarding possibility of getting head. So they are called mutually exclusive events. In a throw of an unbiased cubic die, occurrence of 1 or 2 or 3 or 4, 5 or 6, all of them are mutually exclusive. Because when you throw a dice, let us suppose 3 comes on surface. So naturally, occurrence of 3 simply discard possibility of getting 1, 2, 4, 5 or 6. That is how they are called mutually exclusive events. In a drawing a card from a well shuffled standard pack of playing card, getting a card is a spade or heart. Look, while drawing a card, there are 4 different types. Again, I am coming back to the classification of this playing card. There are 52 cards. Okay. In these 52 cards, 26 of them are of a red color, 26 of them are of a black color. Okay. Among this 26 again there are sub-classification. 13 of the cards are of type spade, 13 cards are of the type heart, 13 cards are of the type diamond, and 13 are the cards of type club. Which there are 4 different types, each of them there are 13 cards. Means 13 spade cards are there, 13 heart cards are there, 13 diamond cards are there, and 13 clubs cards are there. Okay. Now when drawing a single card, getting a spade card and getting a heart card, naturally, while getting a spade card, you simply discard possibility of getting heart. Getting a heart card, simply discard possibility of getting a spade. So they are mutually exclusive. Card is a diamond or a club. Means getting a diamond card, simply discard possibility of getting club. Getting a club card, simply discard possibility of getting a diamond card. That is how they are mutually exclusive. Card is a king or a queen. Getting a king, simply discard possibility of getting queen. Getting a queen, simply discard possibility of getting a king. That is why they are mutually exclusive events. In terms of set theory format, let us suppose event A is there and another event B is there. Event A and event B are called mutually exclusive event if they don't have anything in common. Means both of them are 2 different sets and they don't have anything in common in between of them. Means you will have 2 different circles while putting it in a Venn diagrammatic format. This is called a Venn diagram. With the help of a set theory, mutually exclusive events can be defined as, look, again, we are putting it in terms of technicality. 2 events A and B are said to be mutually exclusive if A intersection of B, which is phi, that is termed as phi. Okay, what do you mean by A intersection of B? While dealing with set theory, there are 2 operations. One is called union and second is called intersection. What do you mean by union? Union means all the elements, whether it is in A or it is in B or it is in both of them. Look, here the word used is whether it is in A or it is in B or it is in both of them. Means a word or, connector is or there. Secondly, if you put an intersection, A intersection of B, what do you mean by that? While putting it intersection means a common element. Means it is in A as well as in B. Means it is in A and it is in B. Here the connector is and. So whenever two events are being connected with the word and, at that time, if you put it in a set theory based example, whenever this intersection is used, always the connector is and. Whereas if it is a union, your connector will be or. Okay. 5. 5 means no elements. This type of sets in a set theory format, this type of events are called disjoint sets. Don't worry about that, it's all fine. Our intention is to define mutually exclusive event, not the disjoint. In other words, when they have no element in common, they are called mutually exclusive event, where it is going to affect. It affects in an addition theorem. There is a probability function, or you can say an addition theorem, which says that if A and B are two mutually exclusive events, then probability of A union B. Try to understand it. When I say probability of A union B means probability of event A or event B occurs, which is equal to sum of individual probability. Means probability of A plus probability of B. Means whatever individual probabilities are there, if you make sum of those two, which gives you probability of event A or event B. Don't panic about this thing, because I have shown the effect of this mutually exclusive events where it is affected. So this is affected at an addition rule of probability. We will see this addition rule in detail in next lectures. Type of events. Overlapping event, or you can say intersection events. Two or more events are said to be overlapping or intersection event if part of one event and part of another event can occur simultaneously in the same trial. Exactly, if you think properly, if you understand it properly, overlapping event or intersection events are nothing but not mutually exclusive events. Whenever overlapping or intersection events are there, they are not mutually exclusive in nature. Let us see it in an example. In a throw of an unbiased cubic die, let us suppose there are two events. Occurrence of a multiple of 2 or 3. Okay, these are two different events. Occurrence of a number which is in multiple of 2. Occurrence of a number which is in multiple of 3. Okay, put it separately. Just think of a number which is in multiple of 2. Which are they? Let us denote it with A. Which are they? It can be 2, 4 or 6. Is it okay? Let us suppose event B is there, which is getting a number which is in multiple of 3. Okay. Possible outcomes are 3 or 6. There are 2 possible outcomes. Okay. Now you just observe it. Throw a die. When 4 comes on surface, what will happen? Event E occurs. Is it okay? Let us suppose 3 occurs on surface. Then event P occurs. It is fine. But what will happen when 6 occurs? When 6 occurs, this 6 is in multiple of 2 as well as it is in multiple of 3. So both this event happen simultaneously. Okay. What mutually exclusiveness says that both the events should not occur simultaneously. What happened here? Here both the event happened simultaneously. So they are not mutually exclusive. Okay, since they are not mutually exclusive, that simply indicates that they are overlapping events, or you can say intersection events. Let us see one more example. In drawing a card from a well shuffled standard pack of playing events, card is a spade and card is a king. If king of spade is drawn, both the events happens simultaneously. Since both the event happens simultaneously, that means they are not mutually exclusive. Since they are not mutually exclusive, that means they are overlapping events, or you can say intersection events. So, concluding it this way, overlapping event or intersection event or not mutually exclusive events are the 3 same terms. They are similar in nature. What happens when this overlapping event or intersection, or you can say not mutually exclusive event happens? Naturally, there are some common ground. Set A, or you can say event A and event B is there, but there are some area which is common in both of them. Okay. If you put it in a set theory format, this is called a Venn diagram. This overlapping events can be shown with the Venn diagram which is shown in this PPT. 2 or more events are said to be intersection event if your A intersection of B is not phi. Means there is some common area. When there is some common area, naturally it is not phi. That simply means that A and B are not disjoint events. In other words, they have something which is common. Where this is likely to affect, again, as we have seen it in the last slide, it will affect in an addition rule of probability. Probability function, probability of A union B, that means probability of A happens or B happens, which is equal to, last time when it was mutually exclusive, at that time individual probability were summed up if they were mutually exclusive. Now they are not mutually exclusive. Since they are not mutually exclusive, some common area is there. Some common area is there that indicates that that common area is to be reflected in formula. So now it is probability of happening of A or B, which is equal to probability of A plus probability of B minus probability of A intersection of B. Means sum of an individual probability, but that common area is to be deducted from it. Right? Okay. We will see it in detail whenever we are addressing this addition rule of a probability. That will make it more clear to you. I am trying to connect all this just because of the impact of this overlapping event and not mutually exclusive event where it is affecting. It is affecting in the addition rule of a probability. Is it clear? Type of event. One of the event is called independent event. Look, this independence is seen with a different perspective. Two or more events are said to be independent if occurrence of one doesn't affect the occurrence of other. While addressing this independent event, one more thing is to be clear. You might have heard some of the words with replacement and without replacement. An experiment is performed with replacement, an experiment is performed without replacement. Let us suppose probability of drawing a spade card from a pack of playing card. What is that? Which is simply a ratio. Ratio of upon it would be total number of possible outcomes. 52 cards are there, one card is selected at random, total number of possible outcomes can be 52, so denominator is always 52. Is it fine? Okay. Numerator. Total number of favorable cases. In how many different ways you can get a spade card? How many spade cards are there in a pack of 52? There are 13. So there are 13 different possibilities of getting a spade card. The number of favorable cases might be 13. So probability of drawing a spade card from a pack of playing card is 13 upon 52. And that of another spade card after replacing the first one, what will happen? Again, the first card is drawn, it is a spade card. You put it back. Again, total number of cards remains 52 as you have replaced it back. Okay. In the pack of those 52, again total number of possible spade cards remains 13. So again, another spade card after replacing the first one is the same, 13 upon 52. So look here. The first card is drawn with a probability 13 upon 52. If you replace it back, the second card is drawn, which again getting a spade card remains 13 upon 52. Hence the result of second trial is not affected by the result of first trial since the card was replaced. Okay. Look, replacing, while you replace it, this event becomes independent because occurrence of first event doesn't affect the occurrence of the another event. Where it is implemented or affected, this is called a multiplication theorem. Probability function, probability of event A happens and B happens. Since the word is and, which is equal to, it is a product of individual probability. So it would be probability of A multiplied by probability of B. But this function is applicable only if they are independent. Occurrence of A doesn't affect the occurrence of B. Okay, when events are independent, if the word replace, if you are replacing, then only they becomes independent. Now let us see what happens when we are not replacing it. Naturally, two events are called dependent events. Two or more events are said to be dependent if the occurrence of one affect the occurrence of other. Let us take the same example that will make it more clear. probability of drawing a spade card from a pack of playing cards is 13 by 52, which remains as it is since it is the first trial, while that of another spade card when the first card being not replaced. If you don't replace it, now how many cards are there? There are 51 cards. Okay, one card which you have drawn, it is of a type spade and you are not replacing it. So how many number of spades cards are left within the set of cards? There are 12. So probability of drawing a second card, or you can say second spade card, being not replaced becomes 12 by 51. Look, in the first case it was 13 by 52. While drawing the second card it became 12 by 51. So look, occurrence of first event affected occurrence of second event. They affected just because of we have not replaced it. Since we have not replaced it, there was an affection or there was an effect of not replacing. Since occurrence of first event and occurrence of second event is affected by occurrence of first event, they are not independent. Since they are not independent, they are dependent. Where this particular thing will affect, as I said it earlier, again it will be affected to a multiplication rule. Now it would be probability of A intersection of B, means probability of event A and event B occurs simultaneously, which is equal to probability of A multiplied by probability of B oblique A. Look, understand it. When you use the word B oblique A, how you are likely to utter, how you are likely to pronounce. This is nothing but probability of occurrence of B oblique means, whereas it is given that event A occurred earlier. Probability of occurrence of B where probability event A occurred previously. If the first event is A and second event is B, or it can be other way out. Probability of event A and event B happens, which is equal to probability of B multiplied by probability of A oblique B. What do you mean by that? A oblique B means occurrence of probability of occurrence of A where it is given that B has already occurred. This notations, whenever we will have a multiplication rule, will come back to this part. Right now our intention is to get the word dependent events clear. Is it clear now? So one thing is very clear, then the experiment with replacement leads to independent events, whereas experiment without replacement leads to dependent event. Whenever a word with replacement is used, independent type of events are there. Whenever the word without replacement is used, they are dependent events. It is as simple as that. Distinction between overlapping events and dependent events. In overlapping, intersection of event is examined, while in dependence, effect of first trial upon the second trial is examined. Look, when I say overlapping events and dependent events, they are two different types. Overlapping event means mutually exclusive events. Those who are not mutually exclusive event, then it becomes overlapping. When I say dependent event, it is altogether different thing. Effect of one doesn't comes on the second one. Can the two events be mutually exclusive and independent simultaneously? Yes, it's a special case. Normally, not, but only in case when probability of not happening of other event is zero, then mutually exclusive event and independent event happens simultaneously, which is a specific case. Type of event. Mutually exclusive and exhaustive events. I am trying to explain it in terms of some example that will make you an idea, a clear idea about the terms. A number of events are said to be mutually exclusive and exhaustive events if the first property is every two of them are mutually exclusive, and the second property, one of them necessarily occurs in any trial. For example, if in an experiment of drawing a card from a well-shuffled pack of 52 cards, the following events are mutually exclusive and exhaustive. Let us suppose event A. The card is a spade, the card is a club, a card is a diamond, a card is a heart. Okay? Look, event A. There are 52 cards of which one card is to be fetched. If that card is of type spade, naturally, while getting a spade card, simply discard possibility of getting club, diamond and heart means a non-spade cards. Okay. Second, if you make a connection of all this spade and non-spade, it gives you a totality. That means they are exhaustive. This is how mutually exclusive and exhaustive are two different things. Exhaustive means if you club everything, it should give you the complete totality. Mutually exclusive means happening of one, simply discard possibility of happening others. All these two possibilities are integrated, then those events are called mutually exclusive and exhaustive events. Right? Now we are connecting two different types, mutually exclusiveness and exhaustive.